Okay, scientific notation. I don't know how much you see scientific notation today, but when I was in school, we used a lot of scientific notation. If numbers were really, really big or numbers were really, really tiny, we would express them with scientific notation because it made it easier to express the number. And so scientific notation is a system used to work with very large or very small numbers quickly. This system uses powers of 10 to facilitate writing these big numbers. A dictionary definition of this is a method for expressing a given quantity as a number having significant digits necessary for a specified degree of accuracy, multiplied by 10 to the appropriate power. That particular definition is a very good one and a little bit technical. Okay, so what does that definition mean? Well, it basically means that you're using the idea of significant digits. You have one significant digit before the decimal point and however many you want after the decimal point. This is what has to happen to be significant. One significant digit before the decimal point and all the others after the decimal point times 10 to some power. Okay? And this is the only case where we start using negative powers of 10 when we're working with exponents. We use it especially with scientific notation because a negative exponent means this number is going to be very small. A positive exponent means this number is going to be big, large, okay? So let's look at things like this. As I say, this is written in two parts. This part is part 1 and this part is part 2. This number here, because it's got to be significant, can only be the digits 1 through 9. So, if we call this C, for example, this is 1 is less than or equal to C, which is less than or equal to 9. In other words, I can't have 0 in that place because 0 would not be significant. I can't have 10 because that would be 2 digits instead of 1 digit. So it has to be that. And secondly, it is 10 to a power, which would be used to return it to the original number if you're going from a decimal number to a scientific notation number. So this can be written as C times 10 to the n, and n has to be an integer. That means it can be any number from negative negative to 0 to positive positive. So it's the integer numbers. And this has already been given. So, when we first start doing scientific notation, first of all, we usually change a decimal number to a scientific notation. So let's look at some of these. If I have 700 and I want to change that number to scientific notation, I have to have only one digit to the left of the decimal point. That means my decimal point has to go in here. So this would equal 7.0 times 10 to what power? Well, if I multiply 7 times 100, it brings me back to 700. And 100 is 10 to the second power. Notice the number of zeros here, or the place values I have to move to get back to the original, is the number that is up there. Okay, let's look at another one. How about this one? 4, 9, 1, 2, 1, 2, 3, 2, 3. Okay? It's a really big number, isn't it? For thousands, millions, billions. 4,900,000,900,000,000. It's a very large number. So our decimal point is going to have to go right here after the 4. So this would be 4.9 times, well, this would be 100 million. Okay? If we multiply this times 100 million, it would give us that number. Okay? Or no, times 1 billion. 1 billion. Okay? 4.9 times 1 billion will give you 4,900,000,000. Okay? So now that number, that 1 billion, can be translated to 10, let's put a multiplication, 10 to the 9th power. You see? From here to the end of the number is 9 places, and that is the power that goes on your on your 10. Okay? So that's changing from decimal to scientific notation. Now let's look at some smaller numbers doing that with. These were big numbers. Now let's look at the small numbers. Decimal point 007, and we can put a 0 in front, although it's not needed. What would this equal? Well, we know our decimal point has to go right here, because it has to go after the first 1 through 9 significant digit, right? So this has to be 7.0 times 10. In this case, we have to move how many places to get back to where our decimal is? 1, 2, 3. It has to move 3 places, but if it's a positive 3, we'd move in this direction. We'd move to the right. It has to be a negative 3 because it's going to move us to the left. So 7.0 times 10 to the 3rd. If I wanted to return, I would go like this, and I would get back to where I started. Okay, let's look at another one. Okay, again, after my first non-zero significant digit is right here at 4.9. So my decimal point has to go there. So this is 4.9 times 10 to what power? Well, how many places do I have to go to get to where I started? 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a negative 9 because I have to move left instead of right to get back to where I started. So here's kind of your rule of thumb. If the original number is larger than the scientific notation number, part 1 number, the exponent of 10 will be positive. Or it could increase. And you'll see that happen when we start multiplying and dividing these things, okay? So that's the first rule. So let's look at an example. What we did, 700 turned to scientific notation, 7.0 times 10 to the second power. 700 is larger than 7. Therefore, my power of 10 is positive, and it's the number of place values that we went from here to get to the end of the number, 2 place values. Okay? The second part of this rule is this. If the original number is smaller than the scientific notation part 1, part 1 number, the exponent of 10 will be negative or it will decrease. Okay? So those are the rules that we're going to apply to this. Now let's look at a few more. Three, 5, 0, 0, 0, 0, 0. Okay? So my decimal has to go between my 3 and my 5. Therefore, this is 3.5 times 10 to what power? Well, 3,500,000 is much larger than 3 and 5/10. So therefore, this is going to be a positive exponent. But what's it going to be? My decimal went there. Count the number of places I have to move to get to the end of my number. And this is 6 places. Therefore, my exponent is 6. Okay, let's look at some practice here. Again, you might want to write these down and do them, and then check them after you pause your 9, 5, 6, 7, 1, 2, 3, 4, 5, 6. Okay, and here's another one. Okay, might want to pause it. Okay, now let's see what happens. Decimal has to go here. 6.57. Because you see, we don't write all those zeros. It's only these significant digits. 6.57 times 10 to what power? 1, 2, 3, 4, 5. Is it positive or negative? This is bigger than that. It's much larger. Therefore, it's a positive. Looking at this one. Again, decimal point has to go after the first significant digit. So this is 3.9567 times 10. What's your power of 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, and is it positive or negative? Well, 3.9567 is much smaller than 39 billion. 2, 3, yeah. 39,000 billion. So it's much smaller, therefore it's a power positive. Okay, now the last one. Again, decimal has to go after my first significant non-zero number. So 3.5 times 10 to what power? 1, 2, 3. Now, 3.5 is larger than 10 thousandths, so therefore it is a negative. Okay? Think you got that down now? It's not so hard to do. Now we're going to look at changing it the other way. Okay? Oh, one more unique, there's another one that I want to put up here. It's a unique case, 3.565. If we were to write that in scientific notation, what would it be? Well, let's see. It already has one significant digit to the left of the decimal point. So this part is in already the form that it's required. So this would be like 3.565 times 10 to the 0 power. Because 10 to the 0 power is equal to 1, so this would be a multiplication by 1, which is why you're using 10 to the 0 power. If there's no change and you have to express it in scientific notation, your power on the 0, on the 10, is going to be 10 to the 0 power. Okay? Now we're going to look at going the other direction on this. So now we're going to change from scientific notation to decimal notation. So, 5.5 times 10 to the 4th. My 4 is positive. It says you're going to move your decimal 4 places to the right. So this is equal to 5, and that's going to be 1, 2, 3, 4. So I've got 3 places that I'm going to have to put zeros in. So it becomes 5.5 times 10 to the 4th is equal to 55,000. Let's look at another one. Let's do the same thing, only move it in the other direction. 10 to the negative 4. Again, we're going to move this decimal 4 places to the left. So 1, 2, 3, 4. So this is going to be 0 point, and then how many places? 1, 2, 3 zeros. Fill in those holes, and then 5, 5. And there it is, going from scientific back to decimal when it's a negative and a positive. Okay? And how about this one? 5.5 times 10 to the 0. That 0 says there's no movement of the decimal, so therefore this is just simply 5.5. Okay, now we're going to look at what happens when you multiply or divide these things. Usually if you're going to add or subtract, the only way you can add or subtract scientific numbers is if our power of 10 is exactly the same. So I could add or subtract if I had 5.5 times 10 to the 3rd plus 3.2 times 10 to the 3rd. Because this here means that it's in exactly the same place value. So this would be 8.7 times 10 to the 3rd. It works like having like terms because this and this are the same. So then we could add or we could subtract them. 5.5 times 10 to the third minus 3.2 times 10 to the third means that you'll have 2.3 times 10 to the third. So as you can see, you're keeping that place value exactly the same. If these 10 to the thirds, if this exponent part, the power of 10 part of your scientific notation is not the same, then you would have to write the numbers out all the way to add or subtract them, or put it in your calculator to do that. So it's, a lot of you use calculators nowadays. I grew up doing these without a calculator. And so I'm going to be teaching you the method to do these without the calculator, even though I know you can stick it in your calculator and do it, okay? So, now let's look at multiplication of these things. Six 0.03 times 10 to the fourth times 8.95 times 10 to the ninth. Now what's going to happen on this? This works exactly like your exponent rules. I have a base of 10 and a base of 10. Therefore, that becomes 10 and its multiplication, so you'll add your exponents, making 10 to the 13. But now I have to multiply part 1 of each one of these, part 1 times part 1. And when you multiply those two together, you get this, 53.9685. Okay, now, what's our problem? Well, 53.9685 is not in scientific notation. Why? Because I have more than one digit to the left of the decimal point. I have two significant digits to the left of the decimal point. Therefore, to become scientific, I'm going to have to move my decimal to between the first and second one. So this becomes 5.39685 times what? Well, 10, because remember I said if it went from a larger number to a smaller number here, if this is larger than this, it's going to increase the power of 10. Therefore, I moved it one decimal point, so this becomes 10 to the 14. And why does this happen on my powers of 10? It's because of your product rule that says if I have some number to a power times another number to a power, and it has to be that same number to another power, then I keep the base and I add my exponents. And if you've had your exponent rules, you should know this, okay? But we'll review it for you. Now, let's look at another example for multiplication of these. Okay. 6.75 times 10 to the negative 3. That number times 9.072 times 10 to the 15. And then 8.25 times 10 to the 8th. Okay, first of all, you're going to multiply this number times this number times this number. And that's going to equal this. 505.197 times 10 to what power? Well, we're going to add these exponents. Negative 3 plus 15 is positive 12, and 12 plus 8 is a positive 20. But now, is this finished? No, it's not, because 505 here is not its scientific notation. To make this scientific notation, we're going to have to move our decimal to 5.05197 times 10. Okay, this was larger than this, so we're going to increase the exponent by the number of places I moved it, which was 2. So 20 plus 2 is 22. Okay, let's look at some more. Don't know if there's, guess we'll keep going. .52 times 10 to the negative 3, and 4.79 times 10 to the negative 6. Okay, again, you're going to multiply these two numbers, and that is going to give you 16.8608 times 10 to what power? Negative 3 plus a negative 6 is a negative 9. But it's not yet in scientific notation. Decimal point's going to have to go between the 1 and the 6, so 1.68608 times 10 to what power? Well, this is larger than this, so I'm going to increase this by 1. Negative 9 plus 1 is a negative 8. Okay, one more. 6.99 times 10 to the 5. 9.69 times 10 to the 9. Again, multiply these two together, and I get 67.7331 times 10. 5 plus 9 is 14. Now, what's going to happen here? It's not scientific. I have to put 6.77331 times 10. This is smaller than that. The original is larger than the scientific. Therefore, increase by 1 is 15, because I moved the decimal one place. Now let's look at division. .34 times 10 to the 6th divided by 4.17 times 10 to the 4th. Again, we divide this first part. 8.34 divided by 4.27 is equal to 2.0, or just 2. And we're going to look at this. Base is the same. Subtract the exponent, so 6 minus 4. So this is times 10 to the 2. Or we can write it as 2.0 times 10 to the 2. So if we were going to turn this back to a whole number, or a decimal number, 2 times 10 to the 2 is 2 times 100, which is 200. Let's look at another example. 9.35 times 10 to the negative 3 over 4.25 times 10 to the negative 5. Okay, again, divide these first two numbers, and that is going to give you 2.2 times 10 to what power? Well, negative 3 minus a negative 5 is the same as negative 3 plus 5, so that is again to the power of 2. Okay? Now let's look at something a lot more complex. 1.79 times 10 to the 8 and then times 6.95 times 10 to the negative 3, all over 4 times 10 to the third, times 2 times 10 to the 8th. Since these don't go evenly, I'm not going to divide it before I do anything. Instead, we're going to multiply the top, multiply the bottom, and then go from there. So the top is 12.4405 times 10 to the 5th. Why? This times this is this number. 10 to the 8th times 10 to the third, negative 3. 8 plus a negative 3, or 8 minus 3, is 5. Over the bottom, 4 times 2 is 8. Times 10, 3 plus 8 is 11. Okay? Now, we're going to divide these two numbers, and you're going to get 1.555 times 10 to what power? 5 minus 11 gives you negative 6. So there it is, and that one's already in scientific notation. Okay, have fun with it. Sometimes in your chemistry they will require scientific notation, other times they will not. So you're just going to have to kind of figure it out from what they ask and what the teacher tells you. So this tells you how to do it, so you'll be able to do it when the time comes. Good luck.